Okay, so we're looking excuse me, maybe the last of our distributions, and it's called the geometric distribution. And this is often dealing with a binomial event, and we're looking at the number of how many failures we have to have before our first success. So for instance, a gambler has a string of losses, wants to know what's the chance of him winning eventually, or if you've got a bad captain's coin toss, you need to maybe look at that as well. Okay, so copy that and come across when you're ready. Okay, so the probability that we have a certain value is the number of failures that we're going to have before our first success. So Q is the probability of failure, P is the probability of success, and S is how many failures do we have before our first success. The mean number will be equal to 1 minus P over P, which is the same as Q over P. The sequence is called geometric because when we look at successive values, the terms are actually the terms of a GP with a common ratio of Q, which you'll find in our examples. So copy that and come across when you're ready. Okay, so we're looking at a gambler who knows that on average they win every 5 bets. Okay, so we're trying to find the probability that x equals 5. We have 5 losses before our first win, or the probability that x is less than 5. So the first one is pretty straightforward. Probability that x equals 5. So the probability, so P success is 1/5, failure is 4/5. So we've got to have 5 failures, and then we finally get our first success. And when you put that in the calculator, according to my calculations, you get 1024 over 15,625. So cancel that down if you can, or write a decimal, but that's the answer. In part B, we want the probability that x is less than 5. So we've got x equals 0 plus x equals 1 plus ... up to x equals 5. Okay, so we've got all those values to do. Now when you look at it, in reverse order, okay, we'll do it in the order that it's actually written. So probability that x equals 0 will be just 1/5. Probability that x equals 1 will be 1 failure, and then your success. Probability that x equals 2 is 2 failures, and then your 1 success. And then finally, like, keep going at probability that x equals 5, the last value, and obviously there's other ones in between, is 4/5. 5 times 1/5. Now we're adding those numbers up. So the first number is 1/5, and then between successive terms is the value Q. So that's what I was talking about on the previous page. Now, the sum of a GP equals A R to the n minus 1 over R minus 1, or it's A 1 minus R to the n over 1 minus R. And it's this second one we're going to use because the common ratio is less than 1. If we use the first one, we'll have a negative on the bottom, which is okay, but we're going to use this form of the GP sum. So, finishing it off, so we've got A equals 1/5. R, the common ratio, is 4/5, and we have 6 terms. Because we're starting at 0 and going up to 5, there are 6 terms. Okay, so the sum to 6 terms equals A times 1 minus 4/5 to the power of 6 over 1 minus 4/5. And don't forget to put that in brackets when you're doing a calculator, I'll just stuff it up. And the answer is 11529 over 15,625, which is as a decimal is about 0.74. Okay. So when you have these less thans or greater thans, you're going to end up with the GP sum. Okay, so copy that and come across. Okay, so we've got our next example, and a die is being rolled until 6 turns up. We want to find that, and X represents the number of tosses until, so it's the number of failures, and then this one will be between 2 and 6. So in the first part, okay, so we just write down probability of success is 1/6, the probability of failing is 5/6. Okay, so the first one, so we got probability of X equals 4. Now just remember that X represents the number of tosses until that turns up. So we got 4 tosses. That means we've got 5 failures before the first success. So there's our 4 tosses. So 4 tosses will be that. And so on your calculator, that will equal 125 over 1296. In part B, probability between 2 and 6 will be 2 plus 3 plus ... up to 6. Okay, so for 2 tosses we've got 1 failure, and then there 1 success, and then 2 failures before our first success plus ... 5, 6. So we've got 5 failures and then our first success. Now this time, when we're looking at the GP, our A value is going to be that. Our common ratio is still the 5, 6, and the number of terms will be 5, because we've got starting with 1 going up to 5, so we have 5 terms. And so S5 equals A times 1 minus R to the power of N over 1 minus R, put that in brackets, and then on your calculator I got this answer, and that's about 0.5 on the calculator. Okay, so copy that and come across, and there's the exercise that we'll be doing from Moodle. Okay, pretty straightforward. Thanks.